Uh, Hi everyone. This video demonstrates direct preference optimization or DPO. DPO is a reinforcement learning technique that trains a model using preference pairs. Well, for example, of a good response versus bad response, let's say. Unlike traditionals, RLHF, DPO doesn't need a separate reward model, making it simpler and more stable. Uh, we'll train it on small LM2 to prefer helpful, harmless responses. So yeah, let's get started. Well, understanding DPO data. DPO requires a special data set format with the three columns: prompt, chosen response, and rejection response. We are using the Anthropic HF data set, which contains human preferences, and each entry has a prompt like how can I be more productive. Then there is a chosen response that's helpful and detailed, and a rejected response that's unhelpful or well harmful. The model learns to increase probability of chosen responses and decreases probability of rejected ones. The beta parameters controls how aggressive the optimizes using 0.1, which is very constructive, which is very conservative. Yeah, the DPO setup, after all the environment has been set up, we come with the configurations of DPO. After loading the model and applying the LoRa adapters, we format the dataset. The HHRLHF data comes in conversation format, so we can extract the prompt and separate the assistant responses. DPO configuration includes standard training parameters plus the beta values, and beta is a temperature parameter. Higher means more aggressive preference learning. So we use just 0.1 for stability. The DPO trainer handles the complex math internally. It computes log probabilities for both chosen and rejected responses and optimizes the policy directly without without need of a reward model. Uh, So the training process done with two batch sizes and accumulation of four, eventually coming it out as eight. Uh, DPO training begins. Each step processes both chosen and rejected responses, calculating their probabilities. The loss function encourages the model to prefer chosen chosen over rejected. Training takes around 15 to 20 minutes for 50 steps. The loss decreasing indicates the model is learning to distinguish good from bad responses, which makes DPO very powerful. It it's the simplicity compared to the traditional RLHF models. Traditional RLHF requires to train a required reward model, then use PPO to optimize policy. DPO does this in one stage by directly optimizing from preferences. It's more stable and easier to implement. So after loading and getting all the data done, applying LoRa as a model, and then applying the DPO as the reward model, or well, the reinforcement reinforcement model, and training it over all the data. We come to the part of testing. So let's get the inference done. So the DPO train model with prompts about productivity, learning, programming, and exercises. The response are noticeably more helpful and structured compared to the base model. The model learned from thousands of preferences pairs, which makes it a good response, being specific, actionable, and comprehensive. Uh, Notice the model avoids vague or unhelpful patterns that are marked as rejected in training. This is alignment in action. The model outputs are better for human match and human preferences for helpfulness and safety. Coming to the output, after getting all the training and everything done, setting it around. Uh, this is the training loss we had. The rewards chosen, the rewards rejected, accuracies, and covers every mathematical steps we could have. Getting done with it, here are the answers for the NLQ based questions. So, well, the simple question, as I said, how can I improve my productivity? It has a very good response. You could read the response if you want. You could just pause the video for that. You might need it. So, yeah. DPO recap. Single stage training, no reward model needed, more stable than PPO based RLHF, and works directly with preference data. Use DPO when you have chosen versus rejected response pairs, want to reduce harmful outputs, improve helpfulness, or align the model to specific preferences. It's simpler than full RLHF but very effective. Preference data can come from human ratings, AI feedbacks, or safety evaluations of any kind. The technique is used by major labs for chatbot alignment. So yeah, that's about it for the DPO. Next video we would cover GRPO for training responding for training reasoning models. So yeah, that's about it for the video. Thank you so much.